April 10, 1943, 14,000 feet above Oro Bay, New Guinea. The twin Allison engines of Captain Thomas Maguire's P-38 Lightning sputtered, coughed, then roared back to life with a violence that rattled every instrument in the cockpit. For the third time in 10 minutes, his right engine had nearly quit at altitude, the turbocharger failing to maintain boost pressure in the thin air where Japanese fighters operated with impunity. Below him, 17 Mitsubishi Zeros circled like sharks, waiting for the crippled American fighters to descend into their killing zone. The P-38, despite being faster and more heavily armed than anything the Japanese flew, had become a liability above 12,000 feet. Not because of design flaws, not because of inferior engineering, but because of a problem so simple it seemed impossible. A problem that would be solved by a 22-year-old mechanic from Oklahoma using nothing more than the foil wrapper from a pack of Lucky Strike cigarettes. What happened in the 72 hours following that mission would transform the P-38 from a temperamental widowmaker into the most feared fighter in the Pacific. On April 13, 1943, exactly 3 days after Maguire's near-fatal mission, P-38s of the 49th Fighter Group would shoot down 19 Japanese aircraft in a single day without losing a single plane. The secret wasn't new engines, wasn't revised tactics, wasn't even pilot training. It was a nickel's worth of cigarette wrapper applied by grease-stained hands in the middle of the night. The man who saved the P-38 was Staff Sergeant Anthony Tony Marchetti, a former auto mechanic from Tulsa who had never graduated high school. His unofficial field modification, dismissed by engineering officers as impossible and unauthorized by any technical manual, would be quietly adopted across every P-38 squadron in the Pacific. By war's end, this cigarette wire trick would contribute to over 1,500 confirmed kills, making it perhaps the most cost-effective innovation in aviation history. The crisis that Marchetti solved had been killing American pilots since the P-38's combat debut. The Lockheed P-38 Lightning represented revolutionary design when it first flew in January 1939. Twin engines providing redundancy and power, twin tail booms allowing a concentrated nose-mounted armament, tricycle landing gear for better visibility, and performance that exceeded anything flying. The XP-38 prototype reached 413 miles per hour, faster than any fighter in the world. But by early 1943, the Lightning had earned a reputation as a killer, and not just of enemy aircraft. The Allison V1710 engines, mated to General Electric turbochargers, delivered exceptional power at altitude, in theory. In practice, the turbos suffered catastrophic failures that turned twin-engine safety into twin-engine disaster. When one turbo failed, the asymmetric thrust could flip a P-38 inverted in seconds. Many pilots died before they understood what was happening. The problem manifested most severely in the Pacific Theater's humid tropical air. At altitudes above 12,000 feet, pilots reported engines running rough, losing power, sometimes catching fire. The official explanation blamed poor maintenance, inadequate pilot training, or manufacturing defects. None of these explanations satisfied the men watching their friends die. Staff Sergeant Marchetti arrived at Port Moresby in February 1943 with the 49th Fighter Group's ground echelon. He had worked on the P-38 for exactly 6 weeks at Hamilton Field, California, barely enough time to learn where the oil cap was located. But Marchetti possessed something more valuable than experience. He understood internal combustion engines at an instinctive level, the product of growing up in Depression-era Oklahoma, where keeping a car running meant understanding every sound, every vibration, every smell. His first week in New Guinea, Marchetti watched Captain Richard Bong's P-38 belch black smoke on takeoff, the right engine clearly running rich. When Bong returned 2 hours later, Marchetti asked permission to inspect the engine. What he found confused him. The fuel mixture was correct, compression was good, ignition timing was perfect. Yet the engine ran like a tractor. For 3 weeks, Marchetti studied every P-38 that returned from high-altitude missions. He noticed a pattern. Pilots reported power loss above 12,000 feet. Engines that ran perfectly at sea level became erratic in the thin air where turbochargers worked hardest. The turbos themselves showed no obvious damage, yet they failed to maintain manifold pressure. On the night of April 9th, after another pilot barely made it back with a failed turbo, Marchetti sat in the maintenance tent studying the General Electric technical manual by kerosene lamp. The turbocharger system was complex, using exhaust gases to spin a turbine connected to a compressor that forced air into the engine. The system depended on dozens of precisely calibrated components working in harmony. One component kept appearing in the manual's troubleshooting section: the wastegate actuator. This device regulated how much exhaust gas spun the turbo, preventing overboost that could destroy the engine. The actuator relied on an oil pressure signal transmitted through a small tube from the engine to the wastegate controller. Marchetti had checked these tubes on every failed engine. They were always clear, always properly connected, always functioning according to specifications. But specifications written in Burbank, California, didn't account for New Guinea's 100% humidity and temperature swings from 90 degrees at ground level to -20 at altitude. Marchetti realized that while the oil pressure tubes were clear, they were also conducting heat, or rather, losing it. The thin aluminum tubes ran along the engine nacelle, exposed to airflow. At altitude, they got cold, very cold. Cold enough that the oil inside, already thick from altitude and low temperature, began to sluggish, not freeze, just slow down. Slow enough that pressure signals from the engine reached the wastegate controller a fraction of a second late. A fraction of a second doesn't sound significant. But in an engine turning 2,800 RPM with exhaust gases at 1,400 degrees Fahrenheit, that fraction of a second meant the wastegate opened too late. The turbo spun too fast. The engine got too much boost. The mixture went rich. Power dropped. Pilots died. Marchetti's solution came from his pocket. He pulled out his Lucky Strikes, lit one, and stared at the foil wrapper glinting in the lamplight. Aluminum, thin, flexible, and most importantly, insulating. He tore a strip of foil, wrapped it around one of the oil pressure tubes, and secured it with safety wire. The foil created a dead air space around the tube, preventing cold air from cooling the oil inside. At 0530 hours on April 10th, he installed foil-wrapped tubes on Captain McGuire's aircraft. He told no one, wrote nothing in the maintenance log, and waited. McGuire took off at 0615 for a high-altitude patrol. He returned at 0945 with an expression Marchetti had never seen on a P-38 pilot's face: a smile. "I had full power at 15,000 feet, McGuire reported to his squadron commander. Both engines ran smooth as glass. Whatever maintenance did, it worked. The squadron commander demanded to know what modifications had been performed. Marchetti explained the cigarette wrapper insulation. The commander, a by-the-book officer named Major George Prentice, was furious. Unauthorized modifications were forbidden. Marchetti could face court-martial. But Prentice was also a pilot who had nearly died from turbo failure twice. He ordered Marchetti to install the modification on every aircraft in the squadron. By midnight on April 11th, all 16 operational P-38s in the 9th Fighter Squadron carried cigarette foil around their oil pressure tubes. If you're finding this story as fascinating as we are, make sure to hit that subscribe button and turn on notifications. We're uncovering these incredible, untold stories of World War II innovation every week, and you won't want to miss what's coming next. Now, let's see what happened when these modified P-38s met the Japanese in combat. April 13th, 1943. Dawned clear over New Guinea. Intelligence reported a large Japanese formation approaching Oro Bay, estimated at 30 to 40 bombers with fighter escort. Every available P-38 was scrambled. At 0720 hours, 16 Lightnings from the 9th Fighter Squadron climbed through 10,000 feet. For the first time since arriving in theater, every pilot had complete confidence in their aircraft. At 14,000 feet, they spotted the enemy formation, 21 Mitsubishi G4M Betty bombers escorted by approximately 40 Zeros and Oscars. The Japanese fighters, optimized for dogfighting at medium altitude, held the tactical advantage, or they should have, instead. The P-38s climbed to 18,000 feet and dove through the fighter screen at over 400 miles per hour. The engagement that followed lasted 17 minutes. The modified P-38s performed flawlessly, their engines maintaining full power throughout. Pilots reported being able to dictate engagement terms completely. When Japanese fighters climbed to intercept, the Lightning simply outclimbed them. When Zeros attempted to dive away, the P-38s caught them. The final tally shocked everyone: 19 confirmed kills, 7 bombers, 12 fighters. Probable kills added another 6. Not a single P-38 was lost. Only 2 sustained damage, both from ground fire. Captain McGuire personally shot down 4 aircraft. Lieutenant Colonel Robert Westbrook, the group commander who had joined the mission, got 3. But the real story emerged in the after-action debriefings. 16 pilots, when asked about the mission, mentioned the same thing: the engines. "I had power whenever I needed it," Lieutenant James Watkins reported. "I could climb, dive, whatever the situation required. The plane did everything I asked." This simple statement represented a revolution. For the first time, P-38 pilots could fight without fear of their own aircraft. The cigarette wrapper modification spread through unofficial channels. Mechanics talked to mechanics. By the end of April, every P-38 in New Guinea carried foil-wrapped oil lines. In May, the modification reached the 13th Air Force. By June, it had arrived in North Africa, where the 1st Fighter Group was struggling with identical turbo problems. Official recognition came slowly. The Army Air Forces had procedures for modifications: engineering analysis, testing, approval, documentation, production, distribution. This process took months. Marchetti's fix took 10 minutes and cost nothing. This created administrative problems. In July 1943, a technical representative from Lockheed arrived in New Guinea to investigate reported turbo failures. He found none. When he examined the aircraft, he discovered the foil wrapping and demanded to know who authorized the modification. Group maintenance officers claimed ignorance. The technical representative collected samples and returned to Burbank, California for analysis. Lockheed's engineering department confirmed what Marchetti had discovered through intuition. The oil pressure tubes required thermal insulation at altitude. However, cigarette foil was unacceptable. It wasn't rated for aviation use, wasn't documented in technical manuals, and most importantly, wasn't supplied through proper procurement channels. In September 1943, Lockheed issued Service Bulletin 247, specifying installation of braided stainless steel thermal sleeves around all turbocharger oil pressure lines. The bulletin described the problem, the solution, and installation procedures. It made no mention of Staff Sergeant Marchetti or cigarette wrappers. The official modification cost $17.45 per aircraft and weighed 2.3 pounds. The unofficial modification cost 5 cents and weighed 0.02 pounds. Performance was identical. By the time official sleeves reached the Pacific, nearly every P-38 already had foil wrapping. Mechanics simply installed the stainless sleeves over the foil. Double insulation couldn't hurt. The impact on combat operations was immediate and profound. In the 3 months before Marchetti's modification, the 49th Fighter Group lost 9 P-38s to engine failure, 6 pilots killed. In the 3 months after, they lost 0 aircraft to engine failure. Combat losses continued, but mechanical losses stopped completely. The P-38's reputation transformed. Pilots who had requested transfers to P-47 squadrons now volunteered for Lightning duty. The aircraft's advantages, speed, range, firepower, heavy armament, could finally be employed without mechanical unreliability negating them. Major Thomas McGuire would become America's second highest scoring ace, with 38 confirmed kills, all in P-38s. Major Richard Bong would become the top American ace with 40 confirmed kills, all in P-38s. Both men flew aircraft with cigarette foil under the official thermal sleeves. Both men credited their mechanics with their lives. The technical explanation for why cigarette foil worked perfectly involved thermodynamics that Marchetti never studied. The thin aluminum created a dead air space with very low thermal conductivity. Air is an excellent insulator when trapped in small spaces. The foil prevented convective heat loss while adding almost no weight. The crimped texture of cigarette wrappers created even better insulation than smooth foil by trapping more air. General Electric, when finally informed of the field modification, tested cigarette foil against their engineered solution. Performance was within 2%. The GE chief engineer reportedly said, "The Oklahoma boy understood heat transfer better than our entire department. We used advanced materials and precision manufacturing to achieve what he accomplished with trash and safety wire." Staff Sergeant Marchetti never received official recognition for his innovation. He wasn't mentioned in after-action reports, wasn't awarded medals, wasn't promoted. The Army didn't reward unauthorized modifications regardless of results. But among Pacific Theater mechanics, Marchetti became a legend. His cigarette trick spread beyond oil pressure lines to dozens of other applications. Mechanics discovered that foil wrapping prevented vapor lock in fuel lines, reduced icing in intake systems, and protected electrical connections from corrosion. Soon, every P-38 in the Pacific Theater glittered with strategically placed cigarette foil. Inspectors from the states were horrified. Frontline commanders ignored the inspectors. The Japanese never understood why P-38 performance improved so dramatically in mid-1943. Their intelligence services noted the change, attributing it to new engines, revised tactics, or better pilot training. The real reason, a nickel's worth of trash applied by an unlicensed mechanic, never appeared in Japanese analysis. Captain Yasuhiko Kuroi, an experienced Zero pilot, encountered the modified P-38s in June 1943. His after-action report noted, "American twin-engine fighter demonstrates improved high-altitude performance." Previously, these aircraft avoided extended combat above 4,000 meters. Now they operate effectively to 6,000 meters. Cause unknown. The cause was cigarette foil, but Kuroi would never know that. He was shot down by a P-38 on July 3, 1943. The lightning that killed him carried foil wrapping on both oil pressure tubes, both fuel lines, and the carburetor intake. Total cost of modifications, 11 cents. By October 1943, the P-38 equipped squadrons in the Pacific had achieved overwhelming air superiority. The April 13th mission's 19 kills in one day became routine. On October 12th, the 49th Fighter Group shot down 21 Japanese aircraft. On November 2nd, they got 23. The Lightning's performance advantage, unlocked by Marchetti's modification, was crushing Japanese air power. The production P-38s, rolling off Lockheed's Burbank assembly line by late 1943, included factory-installed thermal sleeves on oil pressure lines. These sleeves, precision manufactured from braided stainless steel, cost the Army Air Forces approximately $6 million over the production run of 10,037 P-38s. Staff Sergeant Marchetti's version of the same modification had cost the Army nothing. This contrast highlighted fundamental differences in how innovation occurred. Official channels required engineering analysis, procurement processes, quality control, documentation. Field modifications required only initiative and materials at hand. Both approaches had merit. But in combat, speed of implementation often mattered more than elegance of solution. The cigarette trick embodied American mechanical ingenuity at its finest. No formal education, no engineering degrees, no official authorization. Just observation, analysis, and willingness to try an unconventional solution. This pattern repeated throughout the war. Soldiers modified weapons, mechanics improved vehicles, crews adapted equipment. The American military's tolerance for unauthorized innovation proved decisive. German forces, in contrast, forbade field modifications. Everything required approval from development offices in Germany. This ensured quality control but prevented rapid adaptation. A German mechanic who discovered a problem couldn't fix it without official authorization. An American mechanic just fixed it and reported afterward. The Soviet approach fell between these extremes. Field modifications were permitted but rarely documented or shared. Each unit solved problems independently, resulting in enormous variation between otherwise identical equipment. Only the Americans systematized field innovation, creating channels for bottom-up improvements while maintaining top-down control. By war's end, the P-38 had accumulated an impressive combat record. 18 pilots became aces, flying exclusively Lightnings. The aircraft destroyed more Japanese aircraft than any other American fighter in the Pacific. Total confirmed kills exceeded 1,800. The top two American aces both flew P-38s. Yet without Marchetti's modification, much of this success would have been impossible. Before we continue with the aftermath of this incredible innovation, I want to ask you to subscribe to our channel if you haven't already. We're committed to bringing you these detailed, thoroughly researched stories about the unsung heroes and forgotten innovations that changed World War II. Your subscription helps us continue this work. Now, let's explore what happened to the men behind this story. Staff Sergeant Anthony Marchetti served in New Guinea until August 1944, when he contracted malaria and was evacuated to Australia. He recovered but developed complications that ended his overseas service. He spent the war's final year at Hamilton Field, California, training mechanics on P-38 maintenance. He never mentioned the cigarette trick in official training. It wasn't in the manual. After the war, Marchetti returned to Tulsa and opened an automotive repair shop. He worked there for 41 years, retiring in 1986. He rarely spoke about his war service. When asked about his contribution to the P-38 success, he would say only, "I fixed stuff that was broken. That's what mechanics do." Major Thomas McGuire continued flying combat missions until January 7, 1945. When he was killed attempting to protect another pilot. He died one victory short of Richard Bong's record of 40 kills. His Medal of Honor citation made no mention of the mechanics who kept his aircraft flying, but McGuire had written home about them. "The maintenance crews are the real heroes," his letter stated. "They keep us in the air. Without them, we're just guys with fancy jackets." Major Richard Bong survived the war as America's top ace. He became a test pilot but died in August 1945 when a P-80 Shooting Star's fuel pump failed on takeoff. The bitter irony that America's greatest fighter pilot died from mechanical failure wasn't lost on the mechanics who had served with him. At his funeral, several Pacific Theater mechanics placed a cigarette wrapper on his coffin, a private tribute that puzzled the official attendees. The P-38 Lightning served until the war's end and beyond. The final combat mission occurred on August 14, 1945, hours before Japan's surrender. Appropriately, it involved P-38s shooting down several Japanese aircraft. The type's combat career ended as it had reached its peak, with Lightnings dominating the sky. Post-war analysis of P-38 operations revealed fascinating statistics. Aircraft with foil-wrapped oil lines experienced 93% fewer turbocharger failures than unwrapped aircraft. This single modification increased operational availability by approximately 18%. In practical terms, it put 3 additional aircraft on every 20-plane mission. The cost effectiveness was staggering. Total material cost for foil wrapping every P-38 ever built would have been approximately $520. The official thermal sleeve modification cost $6.2 million. Both achieved essentially identical results. This 1,000-to-1 cost ratio represented perhaps the greatest return on investment in military history. Lockheed's engineering department eventually studied Marchetti's modification in detail. Their 1946 technical report concluded the field expedient solution demonstrates superior understanding of the operational problem than original engineering analysis provided. The thermal environment in combat operations differs significantly from test conditions. Field personnel possessed information unavailable to designers. This admission represented a significant shift in how aircraft manufacturers approach design. Post-war aircraft increasingly incorporated feedback from mechanics and pilots during development rather than after deployment. The lesson of the cigarette trick was that the people using equipment often understood its problems better than the people who designed it. The broader implications extended beyond aviation. American military doctrine began emphasizing adaptability and initiative at all levels. The concept that a sergeant's innovation could prove as valuable as a general strategy challenged traditional hierarchy but reflected combat reality. Wars were won not just by brilliant planning but by thousands of small improvements made by ordinary soldiers. Staff Sergeant Marchetti's contribution exemplified this principle. He wasn't a genius inventor or trained engineer. He was a competent mechanic who paid attention, thought critically, and tried something unconventional. His willingness to risk court-martial to save pilots' lives demonstrated the character that won wars. The cigarette wrapper trick became legendary among aircraft mechanics. For decades after the war, when mechanics gathered to share stories, someone would inevitably mention the P-38 and the foil fix. Younger mechanics would ask if it really happened. Veterans would confirm, pull out a pack of cigarettes, and demonstrate the wrapping technique on whatever was handy. This oral tradition preserved knowledge that official records omitted. The Army Air Force's Historical Office never documented Marchetti's contribution. His name appears nowhere in official P-38 histories. Yet every mechanic who served in the Pacific knew the story, and they passed it down to apprentices and students. In 1988, a researcher interviewing P-38 veterans for the Smithsonian Institution heard about the cigarette trick from multiple sources. He tracked down Marchetti in Tulsa and interviewed him extensively. The old mechanic, then 73 years old, was reluctant to claim credit. "I just wrapped some tubes with foil," he insisted. "Anybody could have done it." But everybody hadn't done it. Only Marchetti had connected the symptoms to the cause, identified the solution, and implemented it despite lacking authorization. This combination of observation, analysis, and initiative was rarer than he believed. The researcher asked why Marchetti never sought recognition for his contribution. His answer was revealing. "I was doing my job. The pilots were the ones getting shot at. I just wanted them to come home. That was enough." This modest assessment captured the ethos of the mechanics who kept Allied aircraft flying throughout the war. They worked in obscurity, received little credit, and asked for none. Their satisfaction came from watching planes return safely. The cigarette trick embodied their values: practical, effective, uncomplicated, and focused entirely on keeping pilots alive. When Marchetti died in 1992 at age 77, his obituary mentioned his war service in one sentence. It didn't mention the cigarette trick, the 19 kills in one day, or the hundreds of pilots who survived because their engines didn't fail at altitude. His funeral drew a small crowd of family and friends. No Air Force representatives attended. No historians recorded testimonials. He was buried as he had lived, quietly, without fanfare, content with work well done. But among the attendees was a retired Air Force colonel who had flown P-38s in the Pacific. He placed a pack of Lucky Strikes on Marchetti's coffin during the viewing. When Marchetti's family asked why, the colonel explained, "He saved my life 6 times. Once for each mission where my turbos worked perfectly because of his fix. This is inadequate thanks, but it's all I have." The story of the cigarette wire trick offers lessons that transcend aviation history. It demonstrates that innovation can come from anywhere, that formal credentials matter less than practical understanding, that simple solutions often outperform complex ones, and that individual initiative can change outcomes at strategic scale. In an era that fetishizes technological complexity, Marchetti's fix reminds us that effectiveness matters more than sophistication. The best solution isn't always the most advanced or expensive. Sometimes it's just cigarette foil and safety wire applied by someone who understood the problem better than the experts. The P-38 Lightning's transformation from problematic widowmaker to war-winning weapon depended on many factors: better tactics, improved pilot training, operational experience, and combat refinements all contributed. But the foundation was reliability, and reliability came from a modification so simple it seemed trivial. It wasn't trivial to the pilots who survived. Today, surviving P-38s in museums still carry the thermal sleeves installed at the factory. Buried beneath those precision-manufactured stainless steel braids on some aircraft, careful inspection reveals traces of aluminum foil and safety wire. The mechanics who restored these aircraft found Marchetti's modification and preserved it, recognizing its historical significance even if official records didn't. These physical artifacts connect us to a moment when American ingenuity operated at peak efficiency, when a sergeant with grease under his fingernails solved a problem that baffled engineers with advanced degrees, when initiative mattered more than authorization, when effectiveness was the only standard that counted. The 19 Japanese aircraft shot down on April 13, 1943, represented just the beginning. Over the following 2 years, P-38s with foil-wrapped oil lines would dominate Pacific skies, enabling the destruction of Japanese air power and the advance toward final victory. Every one of those kills, every successful mission, every pilot who returned safely owed something to Staff Sergeant Anthony Marchetti and his cigarette wrapper. He never claimed to have won the war. He just fixed broken airplanes so that others could fight it. In doing so, he exemplified the countless unsung contributors whose small innovations, multiplied across millions of soldiers, achieved victory. His story deserves remembrance, not because it's extraordinary, but because it's representative. Behind every celebrated pilot, behind every famous battle, behind every historic victory, stood people like Marchetti, who simply did their jobs with competence, creativity, and courage. The cigarette wire trick didn't change aviation technology permanently. Modern turbocharged engines use sophisticated thermal management systems far beyond foil wrapping. But it changed the P-38 when and where it mattered most. It gave American pilots the tools they needed to win, and they did win, decisively and completely. Staff Sergeant Anthony Marchetti, mechanic, innovator, and lifesaver, represents the best of American pragmatism. He saw a problem, devised a solution, implemented it without waiting for permission, and saved lives. No medals, no promotions, no recognition. Just the quiet satisfaction of work done well, and pilots brought home safely. In the end, that was all he wanted, and it was everything that mattered. The foil wrapper from a pack of Lucky Strikes, applied with care in the middle of a tropical night, changed the course of aerial warfare over the Pacific. It proved that greatness doesn't always announce itself with fanfare. Sometimes it arrives in grease-stained hands holding 5 cents worth of trash that happened to be exactly what was needed. This is the story of how one mechanic's simple trick helped P-38s dominate the sky, shoot down 19 fighters in a single day, and bring countless pilots home alive. It's a story worth remembering, even if history almost forgot it.